hear much more about now, Jaran. Water cycle management and lightweight aggregate geotechnical applications. Thank you very much. And the title of Jaran's presentation is Lightweight Aggregates in the Lighted Space, Building Climate Resilient Infrastructure. Thank you, Jaran.
Thank you. You're doing fine.
Thank
you. Okay, I'll try to present 8 years of research in 15 minutes. So I get to barely scratch the surface. But thank you for attending. And my talk is Building Climate Resilient Infrastructure with the lightweight clay aggregates. And I'm Jaran Raymond, Manager of Product Sustainability and Development. So, okay. Before we start the fun part, short about the Leca lightweight aggregates. Leca, the company, is a producer of construction materials. LVA is short for lightweight aggregates. And it is natural clay fired in a rotary kiln. What happens? You see the clay expands then 5 times into porous pellets like this. And in Norway, we produce about 420,000 cubic meters of Leca LVA annually. And we have many typical applications, such as geotechnical applications, building materials, filter materials, soil mix, and climate adaptation purposes. And these are some pictures showing the internal pore structure of the material, and it's quite remarkable because you have the pellets have an outer shell of quite hard ceramic material and an inner porous amorphous structure with a lot of interconnectivity and many voids and very, very high specific surface. And this cross-section here shows the shell, and of course these are properties that makes the material very strong and lightweight at the same time. We have a recent addition to the research. Here, fresh out of the print, is a new picture of a CT scan by NGI of a Leca pellet, and this really proves the point that the material is extremely porous and more or less 90-something% voids. So geo applications for Leca lightweight aggregate are quite well known in the sector. It's been used for various types of infrastructure purposes for half a decade, mainly as a lightweight backfill material for load compensation, as a drainage layer and insulating layer for frost protection. This is what we do in Norway whenever you can't use gravel and rock as an aggregate below the roads and railroads. Yeah, and this is a picture showing the upgrading of a railway section, just to illustrate for you the amount of volume of material that is used. And here it can also be air blown, the material for very fast installation. Okay, now to the fun part, Leca and climate adaptation. So climate adaptation, by my definition, is societal adaptation by making infrastructure or the built environment more resilient and robust against climatic changes, of course. And the background here is climate is getting wilder and wetter. We all know that. Densification. By that I mean the urban environment is getting denser and less permeable for water. Asphaltation and buildings are making it so that water has nowhere to go. Floods and sewage overloads causes troubles every year, every season, and increased pollution. We want to solve this instead of sending the water to the local water treatment plant or just into the streets or into the local recipient. We can solve it by local infiltration, proper drainage by using good drainage canals, and detention and retention systems. This is a way to climate adapt. And I want to show you this picture, which I took a couple of years back. This is a European main road. It's a Trondheimsveien in Oslo. there was an extreme rain event, and the whole road turned into a river, and this river just flowed into the local roundabout, the main roundabout, and caused quite a lot of damage and trouble there. Bad climate adaptation. So this is just a few weeks ago. The storm Hans hit Oslo with full force. This is also just where I now live, just recently, and this is the main highway into Oslo. And here you can see the pump truck is trying to pump the water away from the infrastructure. It's not succeeding, and this is the day after someone forgot their car. There were quite a lot of damage that day, and this is just a very, very fine example of how we need to climate adapt in order to protect critical infrastructure. And Oslo municipality has a very good plan that hopefully is going to be implemented in all the other parts of the country. Step one is planning. Failing to plan is planning to fail. And step one is catch, clean, and infiltrate small to moderate rainfalls. Step two is delay and detain runoff from larger rainfalls. And step three, secure safe floodways or from extreme downpours, like 100-year rain events, for example. Yeah, this is Leca. It is suitable for water management as a detention medium. I'll come to that and why we know that. But first, how to build with Leca. Nature-based local systems to prevent overloads. Nature-based, I mean systems that simulates nature's own mechanisms, because many of these mechanisms are gone or are not strong enough to cope with the water. By combining vegetation, typically retention areas, rain beds, etc., soil infiltration, and detention. And by detention, I mean temporary storage of water. So these systems have to purposely be built for this application. You can't really just build a classical infrastructure setup with Leca and just hope it will manage water or detain water. You have to do it from the beginning, plan for it, and tailor the whole area for this purpose. And of course, durable and robust design. You have to design for the future, for frost and melt cycles, against clogging, against all types of challenges. And focus on the hotspots, the critical infrastructure, the exposed buildings that will be damaged, and typical critical areas of infrastructure. You can't protect everywhere from the climate. Yeah, very little illustration there about how you can make a parking lot with a Leca lightweight aggregate here as an infiltration substrate. How we know all this, or how can I stand here and claim this? This is because we participated in Climate 2050 project, just recently closed down. It was 8 years of research, and what I'm presenting is just tip of the iceberg. This is you can go to Climate 2050 and look up all the risk analysis, numerical models, and the all types of publications and papers, and see the hard science behind these claims. It was an 8-year project, and the whole sector was involved there. Yeah, that is just the focus areas, which is basically more or less the whole built environment. Here is from the Sintef lab in Trondheim, and this is how the Leca material was tested at the lab. At the lab here, different materials and build constructions were put up here in this box, and it can measure incoming and outgoing water, and you can simulate different types of weather. Also, there was several pilots, big pilots that we did construct outdoors fully equipped with meteorological equipment, moisture sensors, all water that run in and out of these constructions were measured by weight, and we could really we installed sprinkler systems above the construction, so we could simulate again weather events, which doesn't really happen that often. And we had all types of different layers, construction layers, tested on top of the Leca materials. Any news from the computer? We are back. Okay, ahead of myself. Okay, here's the picture of the pilot, and this data is logged, of course, for use in numerical analysis and modeling, and you can also watch everything real time online. And conclusions are very, very shortly. Different types of Leca has different detention capability. That is water storage capability, or not storage, but intensity, runoff intensity reduction. So the green area here is with the Leca layer, and the integral is the amount of water that is detained in the material. And here you see the finely crushed material, coarsely crushed, and round material, which is around, which is round, and then has some detention capability, but is mostly draining. But of course, if you have large volumes of this, it will provide a significant contribution to the detention of an area. Very cute illustration there. This water instead illustrates a peak runoff reduction of how it can be done by running through Leca. This water is then delayed and moved. All water actually exits the system, but it takes a lot of longer time. So it looks like this, a bucket with holes, and around if you do it properly, if you use your creative strengths, you can make a system that will half the flow rate and contain half of the water around an hour, and reduce the runoff intensity, which is the thing you want to reduce. I made a small illustration here about how to construct a piece of infrastructure. This is asphalt, permeable asphalt here, and of course you need some sort of bed to support it. I know that you don't necessarily do it exactly like this, but you need a load-bearing base layer of rocks and gravel. Permeable separation geotextiles are important to prevent intermixing, of course, and then a sub-base layer of Leca material. For example, crushed for maximizing the detention, or if you want a combination, you can use different tailored Leca materials for this purpose. Here you see water is coming in, and water is trickling down to the gravel into the Leca. It's getting detained there and infiltrated. And here, not all subsoils can be have infiltration capacity, or it might be even saturated, and then you will have need a drainage system. It could be either go out to the local recipient or into the drainage system to the water treatment plant, or a secondary detention pond, or somewhere else. The water will be detained and delayed for about an hour, at least half of it, and then exited. If you feel really bold, you can make something like this. This is just an example. You don't need concrete slabs here, but here you have a membrane protecting the whole system. This is a restricted outlet, so the restrictor itself will be the defining parameter for the outlet flow. So you don't need anything else than the round and crushed Leca. And here this fills up with water and acts as a subterranean water detention pond. Well, this is just made for light traffic, for perhaps a parking lot, not for heavy traffic, of course. But use your imagination. Benefits are many. My favorite benefit is that these systems generally can be used to create great outdoor areas, and Yeah, and it's cost efficient comparing to the traditional pipes and tanks that are hard to put into place, and many other biodiversity, cooling, air quality, pollution removal. So now, at last, I want to present to you my e-Kvartalet in Lillestrøm. Just a recent project we just finished. You see here the courtyard and high-rise building around it. All the water from these high-rise buildings, instead of getting led into the infrastructure, is getting led into the courtyard. The courtyard has construction built up similar to what I just presented you, with a Leca, crushed Leca on the bottom, 7 to 40 centimeter, and load-bearing layer on top of that, and patio, or I think it's paved stones, or different vegetation on top of that. And it looked like this now. It's just recently opened, and you can go and have a look if you have time. Lillestrøm is like half an hour outside of Oslo. Since I have not more time, I will show you very short, show you this. It's a similar system made in Sweden. The courtyard will act as a detention pool. You build up with Leca material inside the pool, and the whole subterranean volume will be available for space for water storage temporarily. There will be no permanent storage, of course, and then it will be let out to appropriate system. This is one of the first ones, 50 centimeter of crushed Leca. It's a roof, and all the water in the surrounding block is led into this roof, and then it's detained there, and it's gradually let into the drainage system. And this is, of course, the restrictions that have been put on by the municipality. They are the ones that decide how much water you're allowed to let into the drainage systems at any time. We have calculators based on the Climate 2050 research. It's condensed there. You can just check out different materials and different configurations and just see the theoretical effect. It, of course, will depend on how you construct. And we also have a handbook that you can read more about Leca LVA here. And that is all from me. Just contact me if you have questions.